All right, let's dive right in. Today, we're going to pull back the curtain on something you do dozens, maybe even hundreds of times a day without a second thought. We're talking about browsing the internet. We're going to follow the incredible journey of a single click from your screen out into the world and back again.
You know the feeling, right? You click a link and poof, a website just appears. It feels like magic. But what's really happening in that tiny sliver of time? Well, it's not magic at all. It's an unbelievably fast and complex journey that your request takes across a global network. So where does it all begin? It kicks off with that simple action, a click. The moment you do that, you're not just clicking a button, you're creating a message. You're essentially telling the internet, hey, I'd like to see this information, please.
And instantly, that simple request transforms into digital data. But this little piece of data can't just wander out onto the internet on its own. Nope, it needs to be properly packaged and addressed so it knows exactly where to go. And this is where a really precise set of rules comes into play. Okay, so how on earth do you get a piece of data ready for a trip across a network that connects billions of different devices? Well, you have to follow the rules, a universal rule book that every single device on the internet has agreed to so they can all speak the same language. And that rulebook is called a protocol. You can think of it as the official language of the internet. Without these strict rules, it would just be total chaos. It's how your laptop, your router, and the server on the other side of the world can all understand each other perfectly. Now, when we talk about these rules, there are two main blueprints people refer to. On the right, you've got the OSI model. It's a fantastic 7-layer theoretical guide that's perfect for learning how networks should work. But on the left, that's the TCP/IP model. It's simpler with just 4 layers, and it's the one that's actually running the show. It's the practical, battle-tested workhorse that powers the internet we use every single day. So that's the one we're going to focus on. So, this key process is called encapsulation. And honestly, the best way to think of it is like putting a letter inside a series of envelopes. You start with your raw data. That's your letter. The first layer wraps it up and turns it into a segment. The next layer adds another wrapper with the destination address, turning it into a packet. And finally, the last layer puts it in one more envelope called a frame, which has instructions for just the very next stop on its journey. Each layer adds a new set of instructions. All right, so our data is all packed up and ready to go. But where exactly is it going? Just like a letter in the mail, our digital data needs an address. In fact, it needs a couple of them to find its way. And this is where it gets really clever, because there are two different kinds of addresses working together. The IP address, that's the big one. Think of it as the final destination, the full street address of the server you want to reach. But then you've got the MAC address. That's a local address for only the very next device in the chain. So your data makes all these tiny little hops from one MAC address to the next, all while keeping its eye on that final IP address prize. It's incredibly efficient. And the devices that make all these decisions, they're called routers. A router is like the post office of the internet. It doesn't care what's inside the packet, it just reads the IP address on the outside, looks at its map of the internet, and says, okay, the best way to get there is to send you this way next. They're the traffic directors that keep everything moving.
So we've got our data packed and addressed. But how does it physically get from point A to point B? What is the actual highway it travels on? Because it's not just floating around in the ether. It's moving through a massive physical infrastructure.
For short distances, like inside your house or office, the most common highway is a plain old copper cable, like the Ethernet cord plugged into your computer. It sends your data along as tiny little electrical pulses. It's a real workhorse, but it can be affected by electrical interference.
But for the long haul, we're talking about fiber optics. This is the big leagues. Instead of electricity, these are tiny strands of glass that transmit your data as pulses of light. They are blazingly fast, can carry an unbelievable amount of information, and they're totally immune to interference. These are the cables that run under our oceans and across continents, forming the true backbone of the internet. And of course, there's wireless. When you're on Wi-Fi, your data is being converted into radio waves and literally broadcast through the air. It's incredibly convenient for sure, but it has its own challenges, like a limited range and interference from other signals. For most of us, this is the very first and the very last leg of our data's journey.
So after zipping across copper, light, and air, and being expertly guided by routers, your little data packet finally arrives at the server. The journey is over, right? Well, not quite. Now the whole process has to happen in reverse.
This is called de-encapsulation. The server takes that frame and starts unwrapping it. It takes off the first layer to find the packet. It unwraps the packet to find the segment. And finally, it opens the segment to reveal your original data, that simple request you made just a fraction of a second ago.
So let's do a super quick recap of that whole trip. You click. Your data gets packed up into a frame. Routers guide the packet using its IP address. It travels across a physical network of cables and radio waves. And finally, the server unpacks it. But remember, that's only half the story. The server now has to prepare the website you asked for and send it on that exact same incredible journey all the way back to you.
And the truly mind-blowing part? This entire round trip happens millions upon millions of times every single second, all across the globe. It's a perfectly choreographed and visible dance of data happening constantly, all around us. And it just makes you wonder, with a system this complex and this efficient already running our world, what incredible things will this hidden world of data allow us to build next?